Hello, this is Shushmita and welcome to the Physics Cafe for IIT JEE and NEET. This is session 3 of units and measurements, and in this session we are going to talk about significant figures. In session 2 I had given you some homework separately for IIT and NEET. Hope you were able to solve it. Later on I will be providing you a video solution class for that also. Let us now start our class for today without further ado. Let us first understand what we mean by reliable digit. Suppose we have the regular centimeter scale that we have at home, and this is 0, this is up to 1 centimeter. So this distance is 1 centimeter. That means that, as you can see, there are total 10 counts. From 0 to 1 there are total 10 lines that divides the scale. So our centimeter scale can measure up to the accuracy of 0.1 centimeter. Now we want to measure an object, and if the object have the size like this, then the front of the object coincides with this line over here and the end coincides with this line. So the size of the object we can write it as 0.5 centimeter. But if our object has a length like this, so the end of the object falls somewhere in between these two lines. Now we do not have any line that divides the scale further, so if we take the measurement of the object from here, it will be a non-reliable measurement. We can approximate the value, however, starting from 0 to here, we can write 0.9 centimeter and we can approximate it as 5 because it appears to be in the middle of these two. Therefore, we can take it as 0.05, which is half of 0.1. But then this is not a reliable figure because our scale does not provide for the provision of measurement of it. Though this is an non-reliable figure, but if we are asked about the significant figures in the digit, it will be 2 digits. This is 1 and this is 2. So I hope we understand the difference between significant figures and reliable digits. Moving on, I will give you some examples for the better understanding of significant digits. Whole number like this one, 4, 5. These have two significant digits, one is 4 and one is 5. If we write a number 9, 8, 3, 4, so this has 4 significant digits, 1, 2, 3, 4. If we add a decimal point after a whole number, which is also a whole number, this means it has two significant digits, one is 4 and another one is 5. So if we are to write 4.55, this has 3 significant digits, one before the decimal point and 2 after the decimal point. But if we are asked to count the significant digits of 4.55 with a resolution of 0.1, that means we can take the measurement up to 0.1. So this digit over here becomes insignificant. So this will have two significant digits, one is 4 and one is the 5 right after the decimal, because our resolution is 0.01, and in this case we will have to round off the number. I'll tell you the rules for rounding off also. So if the last digit is equal to 5 and the digit just before it is an odd number, we should add 1 to that. So our rounding off the number will become 4.6, and this is our answer. Moving on further, if 0 comes after a whole number, so there is no decimal in the beginning and 0 comes after that, so this figure over here have only two significant digits. One practical example is we measure length between 2 points at 4500 meter. This can also be written as 4.5 kilometer, which does not require these two zeros over here. So this has two significant figures, and this number also has two significant figures because the zero after it has no extra meaning. The zeros after that add no extra meaning to these two digits. But things changes when we add a decimal to a number. Though there are many zeros in between this number, but the significant digits are 1, 2, 3, 4 and 5. So this figure over here has 5 significant digits. So zeros in between count as significance figures. Now let us look at this number. If there are zeros right after the decimal and the number also begins with 0, so number beginning with 0 and have zeros after the decimal, these zeros does not count as significant figure. So the significant figures in case of this number is only 2, 4 and 5. But the case changes when the zeros come after the decimal. Like in case of this example, the zeros come after the decimal and there is a digit before the decimal as well. So this digit over here, this number over here has 4 significant digits. All the digits in this number are significant. If we were to write 0.500 instead of this 4, if I write 0, then also this has 3 significant digits. Look at this number carefully. It starts with 0 and there is a 0 right after the decimal. As I have told you, as per this rule, this 0 does not count. So this figure has 3 significant digits, 4, 5 and 0. Now let us study this number over here, 450.00. It has a total of 1, 2, 3, 4, 5 significant digits. Because the zeros after the decimal count as they were measured up to that accuracy. But as I told you earlier, that the trailing zeros in case of an integer may not be significant and may not be count. Like this data over here can be written as it is 45,000 meters, which can also be written as 45 kilometers. So it has 2 significant digits. Let me tell you the rules for rounding off a number. If we want to round off this number, so this number has how many significant digits? 1, 2, 3, 4, 5, 6 significant digits. It has 6 significant digits. We want to say round it off up to 5 significant digits. So 1, 2, 3, 4, 5. We want to keep only 5 digits. Now 7 and the number after 7 in the n plus 1th position. Let us call this 5th position. So this is the 6th position and the number 7 is greater than 5. So we will add 1 to this digit over here and our number will become this. This is the number which is rounded off up to 5 significant digits. What happens if the number is like this? So we want to round it up. This has 3 significant digits and we want to round it up to 2 significant digits. So this is the last digit is equal to 5. If the last digit is equal to 5, in that case the rounding up depends on the number right before it. As it is an even number, it will remain unchanged. If my data was like this and I wanted to round it up to 2 significant digits, this is equal to 5, and if this is an odd number, we will add 1 to it and it will be rounded off to 1.4. So if the last digit is 5 and we want to round it off to the significant digit after the previous one, if it is even, it will remain the same as it was. If it is odd, then we will add 1 to it and we will round it off. Now if our digit is like this, it has 4 significant digits and we want to round it off to 3 significant digits and the last digit is less than 5, so this number will remain unchanged. the rounded off number will be 1.85. I hope it is clear to you. So if my data is 1.852 and we want to round it off to 2 significant digits, then our number will remain unchanged. If my data is 157 and we want to round it to 2 significant digits, then as the last digit is greater than 5, so my number will become 1.86. Also, if my data is like this and I want to round it up to 3 significant digits, sorry, this would be 3 significant digits, 1, 2 and 3, 1, 2 and 3. So I want to round it up to 3 significant digits. This is equal to 5. So, and this is even. So my data would become 1.82. And if it was 3 instead of 2, then it would have become 4 over here. I hope it is clear to you. We'll move on to the next topic. Now look at this integer options over here, 1, 2, 5, 6. This is 4 significant digit, and suppose say we want to round it off to 2 significant digits. Therefore, we want to keep the first 2 digits only. Looking at the next digit, which is equal to 5, and the digit before this is even, so our number will round off to 1, 2, and we will put 0 for the next numbers. If our number is 1, 4, 5, 5, 6, look at the next number, and we want to keep, say, we want to round it up to 4 significant digits. Now the last digit is 6, which is greater than 5, so we will add 1 to this digit and our rounded off number will become 1, 4, 5, 6. This is how we will round off the integer numbers. This is an interesting table. The questions may come in 2 types of formats. In one, they will be asking you to round off your number to a certain significant figures, like this is a figure that has 6 significant digits. If you see 1, 2, 3, 4, 5, 6. If we round this off to 5 significant digits, that means we want to keep the 5 digits over here. So the last digit, which is 0, that means less than 5, so it will remain unchanged. Now we want to round up this number up to 4 significant digits. That means we want to keep the first 4 numbers. The last number is equal to 5 and the number before that is even, so it remains unchanged. Next, we want to round up to 3 significant digits, means we want to keep up to here, and 4 is less than 5, so this again remains unchanged. Now we want to round it off to 2 significant digits, so we want to keep the first 2 digits, that becomes 1, 2, and if we want to round off 12 to 1 significant digits, meaning we want to keep only this and the next number, which is less than 5, so 1 remains unchanged and we put 0 instead of this. This is one type of problem when they will ask you to round off a number to significant figures. They may also ask you to round off to decimal places, like to 100th decimal place or to 10th or to 1000 places. In those cases, how we are going to do it? Look carefully over here what we understand by decimal places. Decimal places means the number of digits after the point decimal over here. So 6 decimal places means there will be 6 numbers after the decimal, 1, 2, 3, 4, 5, 6. If we want to round it off to 5 decimal places means we will reduce this 0. If we want to reduce it to 4 decimal places, that means we will keep 1, 2, 3, 4 and then we will cancel this off. Up to 3 significant digit means 1, 2, 3 and we will let it go. 2 significant digit means we will keep 3 and 4 and we will let 5 go. Now 5, which is equal to 5 and the digit before this is even, so it will remain unchanged. Now we want to reduce it to 1 decimal place, that means we want to keep up to 3. The next digit is less than 5, so it will remain unchanged. And up to 0 at decimal place, meaning there is no decimal after 12, so it becomes 1, 2. Hope it is clear to you. Let us solve the problem. Right over here, they have asked us to multiply 2 digits, 45.5 with 680, 1.2. Now in the rule for multiplication and subtraction, we will have to take care of the number that has the least number of significant digits. In this case, 681.2 has 4 significant digits and 45.5 have 3 significant digits. So our result cannot have more than 3 significant digits. Now let us multiply these two using a calculator. Which is 30994.6. So our answer is 30994.6, but we can keep only 3 significant digits. At the next digit, which is greater than 5, so we have to add 1 to 9 and it becomes 310, and we will have to put 0 for the next 2 digits and our answer becomes 31000. So the next problem is the case of a simple addition. 156.32, we have to add this to 6004.6. The same rule will apply here a little bit differently. So in case of addition, we will look for the digit that have lesser number of digits after the decimal places, and in our case it is this number. So we will write 6004.6 as it is, but we will have to round off this number. As this is less than 5, so it will remain unchanged and this number becomes this. We will add these 2 over here, this becomes 10, so 60, and this is our answer. So unlike in the case of addition and multiplication, unlike the case of multiplication and division, in case of addition and subtraction, we will look into the places after the decimal, and the number that has the least number of significant digit after the decimal place will count. In this problem, they are asking us to round off two numbers, and they are asking us to round it off in terms of significant digit. So our first number is 7475. So this is 5 significant digits. As we can see, they want us to keep up to the 4 significant digits. So the next figure, which is equal to 5, and the number before this is odd number, so it will become, we will have to add 1 to 7, which becomes 8. In case of another example, let us take this over here, 7465. Up to 4 significant digit means up to 6, and this over here is equal to 5, and the number before that is even, so it will remain unchanged, and this is our answer. Look into this example, 5.700 meter. Next, they are giving us 570.0 centimeter, and the other example is 5700 millimeter. I have already told you that the zeros after the decimal point will count as significant figure. So this has a total of 4 significant digits. This 0 is also after the decimal, and this 0 is before the decimal but is preceded with numbers. So this also has 4 significant digits. But this is a whole number integer over here that has 0 in the end. So these 2 zeros does not count. This has only 2 significant digits. And that concludes our class for significant digits. This is session 3 for today. In our next session, we are going to learn about errors, the different types of errors, and we will solve a lot of problems involving error calculation. We will also learn about vernier calipers and screw gauge. So see you in the next session. Till then, take care. Bye bye.